Hello all. Let's start the studying paper Context-Based Marwari Text Clustering. The authors are Pranav Malani and Prafulla Bafna. We are from Symbiosis Institute of Computer Studies and Research, Symbiosis International University. When we are talking about this context-based clustering, first let's understand what is the need of context-based text clustering and what it actually means. If you see on internet, we get lots of textual information, and this textual information creates information overload. So managing this textual information becomes difficult, and if we could manage this information in a, systematic manner, then it can support different types of applications. So managing textual information is one of the challenges, and lots of techniques are available for English language, but for the regional languages like Hindi, the techniques have scarcity, and that's why we have chosen this topic. So I have talked about the need of the technique. Let's understand actual text clustering process. So you can see here disorganized documents. So documents are present in a very disorganized way. Those are not present systematically. Different types of documents exist in unorganized way, and that's why there is need to have the groups of the documents, which is referred as text clustering. So we have textual documents which are present, and these textual documents can be combination of personal documents, technology related documents, entertainment related documents, sports related documents. So to make available these documents in a systematic manner with the groups which represent the topic of those documents is the need of an era. Now let's look into how this topic has evolved through literature review. So literature review says that the grouping is a challenge because grouping of the text documents, though it is being done, but the accuracy of the grouping is not calculated very perfectly, and evaluation techniques that grouping is being done, or the performance evaluation of those clustering techniques or grouping techniques, is again the challenge. And that's why to get the exact clusters is the challenge, because the main problem is the terms which are present in the document, those terms are considered as features, or those terms are considered as attributes, and just considering this term is not sufficient. The term should be considered with respect to their synonyms, with respect to the other types of related terms, that is termed as hypernyms, hyponyms, etc. So what literature review says is, because these the concepts are not being used in the clustering, we are having less accuracy for the text clustering. And the same approach we have chosen in the research methodology. You can see that what we have done is we have constructed and pre-processed the corpus, and then we have proposed three methods, that is grouped entity document clustering. As it is related to the Hindi language, you can see H, that word which represents Hindi, at the end of the each technique. So first we take the corpus, then we formulate grouped entity based document metrics. Also we formulate vector space metrics, and we formulate high sensate vector space metrics. After formulating these three types of matrices, we implement clustering on that, and then we compare the evaluation within the proposed techniques as well as with the existing techniques. And then after we get the cluster names assigned to each of the document group, and certainly every document gets its corresponding group, and then we can implement classifier to get the position, or to get the exact class of the new document. So here our research methodology, you can see. After research methodology, you can see here pre-processing results. So this corpus size we have varied from 62 to 1223. So more than 60 till more than 1000 documents are being processed set wise. So here it shows scalability also. If you process 62 documents, then feature set tokens are considered as feature set, So tokens are reduced from 13,000 to 3,000. So roughly I'm talking about these figures. For 420 documents, it reduces from 42 to 3,000. So likewise it is being done, like you can see that for more than 1,000 documents the synset is reduced to 9,000 synsets. So you can see a dimension reduction, and that is also one of the causes of getting the accurate results. Now let's see term and TF-IDF count. So here in the languages, in English and Hindi, both languages, we have mentioned our terms and their respective term frequency inverse document frequency count. You can see these terms indicate the important terms which are selected by the technique. Now here you can see that term and TF-IDF bit which is in normalized manner. So this is just the sample metrics I have taken to understand that how we are considering term and its normalized TF-IDF weight. So all TF-IDF weights will lie between 0 to 1. Now here if you can see in the previous slide we were having only one attribute over here. Now we are having two attributes over here because the two attributes which are related with each other are combined together, and that we term as synset. To evaluate HSV SMM, that is high synset vector space model, for that we use coherence count, and if this coherence count, if you can see, it is highest for uh, 3 value, that is on x-axis. If you see here, this coherence count is highest. So here we have evaluated coherence count, and if you see here for VSM, that is vector space model, the coherence count is maximum at 4. So for VSMM we validate coherence count as 4. And then topics and the representative words, here you can see that for first topic, for second topic, and for the third topic, how the words are being contributed. Now, what I have done is for each and every topic, I have shown different types of words which are being retrieved. So, by using our domain knowledge also, we can decide the topic of each of the groups. So here you can see that clustering that I have told in research methodology already, that we are implementing clustering. So here this is the dendrogram which clearly shows that how the three groups are being formed. So these typical documents belong to one group, and that's why they are combined in one group. So what we have done is, first we have taken the matrix. On matrix we have applied cosine similarity measures, which is the distance measure or a similarity measure, and depending upon the cosine similarity measure, different documents are together. These documents are collected together, and these different types of documents, you can see here, these different types of documents are grouped. So we can say that this particular group of documents belong to some technical documents, these documents belongs to some story related documents. So depending upon their features or the terms which are present, we can decide the name of that document group. um, we have used classification also. So in classification, to validate that, we have used Silohets coefficient. You can see here Silohets coefficient is being applied, and then you can see here actual words which are present are being represented in a diagonal manner of this matrix. And then we, for the proposed technique, we have done the comparative analysis, and you can see here that entropy is minimum and purity is maximum for the proposed technique. So this is the comparison between the existing technique and the proposed technique. We can see here that, as I have told already, that literature review says that there are different types of challenges exist as far as text documents are being considered. The text clustering is not still evolved. Probably it is evolved for English language, but for regional language it is not being evolved. The problem is scarcity of the resources which are available, and that's why how to use different types of word nets to have synsets, or different types of synonyms, meronyms, different types of term related words, how to incorporate that with respect to the clustering or classification. That is one of the problems. And after incorporating that, how to have evaluation measures to calculate their accuracy. So this is all.